Yo, yo, Algebrainiacs! Welcome to the Johnson General Video Hour!
But it's not an hour. This one could be.
Yeah. Buckle your chin straps, folks. Here we go. All right, rational expressions. The first 5 letters of rational spell out ratio. That means it's one number over another number. Now, you're used to pretty easy ones. Adding and subtracting fractions. You get a common denominator. For rational, we have to do the same thing, but we're going to practice with an easy one first so you kind of get the idea.
I want to point that out.
Oh, that doesn't have an equal sign.
That's important because later on we're going to do problems that do have equal signs. Those are equations, and it's important to remember that if you don't have an equal sign, it's not a scale. You can't keep it even on both sides. There's no both sides.
Okay.
We're getting ahead of ourselves, but all right.
That's all right. Okay, so here's a very simple one that you've practiced a little bit. So common denominator is the best way to do this.
Okay, so the common denominator is 8, I know that.
We know it's 8, but why is it 8?
Well, factors of 8 are 4 times 2, right? So they both share this factor of 4. They do not share the 2, however.
But in order for them to both fit into the denominator, they have to include that extra 2. So you have to do what they have in common plus what they don't have in common. Right. Multiply by what they don't.
Right. So the common denominator is 8. So if we actually don't need to change this first fraction to a denominator of 8 because it already has it.
Right.
But this one does not have a denominator of 8. So how do we deal with that?
Multiply it by 2, but you can't just change the bottom without changing the top.
So what do we call this thingy?
A useful form of 1.
Good, because it's legal to multiply anything by 1 even without an equation. We can just modify its form. Right. So 1/8 is not changing. What does the second fraction become?
6/8. Okay,
now are we allowed to add those together?
Yes.
That is no different than 1 plus 6 all over 8.
All right.
And that is?
16/8? No.
No, I don't think so. You're so funny.
Yeah, no.
Okay.
Not really.
All right, so we're kind of working our way into these examples. So we're going to do one more little warm-up type of problem.
Okay.
Finding the LCM, which is known as the least common multiple. And we're allowed to leave them in factored form.
Like, what do they have in common? What's the smallest thing they have in common?
So first thing we need to do is factor those polynomials. So what do you think about that?
Factor means we're probably going to bring in some parentheses, right?
Right.
That's usually what happens. So the first one, I say they both have a 2 in common, so we bring that out front, leaves x plus 2.
Okay.
The second one is a quadratic, so we've done lots of these. 6 is 3 and 2, probably minus 3 and a plus 2.
Because we want to multiply to get -6, but add to get -1.
All right.
And we've reviewed some factoring in 8.
Okay.
All right, so we're kind of at the step where we were looking at this as 4 times 2.
Right, because those are the factors of 8.
Right.
We just break it up into its parts.
So here, write down the common factors. So what do the polynomials share?
Both have x plus 2.
Okay, now that takes care of one factor of x plus 2 in those. In fact, if there was more than one, it would only take care of one of those. All right, and then that takes care of all the stuff in common.
Okay.
So what have we not included?
The 2.
The 2 from this guy and
the x minus 3.
good, and we're allowed to leave that in factored form. So that's it.
So that if we were trying to add those, like they were bottoms of fractions, that would be the
bottom of both of them.
Right, that would be the common denominator.
Right.
That means all the parts fit into it. This 2 fits into it. Whoopsie. My bad.
I'll save you.
That's good. This 2 fits into it because of that. Woo, look at that. This fits into it because of that. This fits into it because of that. And this fits into it. They all fit in there somehow. They all, like a puzzle, will fit in there.
Let's try another one. What you got going on? I'm on board.
Okay, whoa. All right, factor it first. 2 parentheses. I'm going to say x minus 4 and x plus 1.
X plus 4, x minus 1. So that's the first one. I'll take the others. I got my writing all pretty close here. Okay.
And 8 would be 4 and 2, x plus 4.
More
Minus
pluses
2.
left. Yeah, that makes sense. And then for the last one, factors of 4 that have to be -4.
Minus 2, minus 2.
It is -2, which you could write like this, but I will tell you for right now, you might want to write it twice just so you can see what we're going to do next.
Right, because you might need both of them.
Alright, so this would be if we were trying to find a common denominator between 3 fractions.
Whoa.
So what is shared?
They all, or
No.
at least 2 of them share.
Right. So this,
That's one of them.
so I'm going to write it down, and that means that we don't need to use it again. Anything else?
The x minus 2 is shared.
Okay, but that only takes care of 1, so let's write it down and cross those off. And then what
No
have we
more
not
sharing,
used?
so we haven't used x minus 1 and the other
Okay.
x minus 2.
And that would just be that there's 2 x minus 2, so I'm going to do that like this.
So that would be the common denominator if those were all in the bottom of the fraction we're
Yep.
adding. Got it.
Alright, why do we need this?
Well, when you're adding rational expressions, they can have just about anything. They're not very simple.
We're going to uncover our steps, and you can hit pause and copy those down. Okay.
All right, we're back. Let's go step by step here. We're going to factor the denominators just like we did on the last screen.
Mm-hmm.
So that first one looks like there's nothing that can be taken out.
Yeah, it's
So
already factored.
done.
Great.
The second one, they have x in common, so we're going to factor that out front.
So what do you notice about those?
So I'm going to take an x out front, and then I get x minus 1. Ooh, I see they share an x minus 1, so that's part of my common denominator.
Okay, so I'm just going to go up here and write something about the least common denominator, which is really the least common multiple. So you
Right.
said they share x minus 1.
Yep.
Anything that is not shared that we
The
should include?
leftover, yeah, the x.
Okay, so the least common denominator is x minus 1, which, if you notice on this fraction, that already has that.
Okay.
Which is
It's kind
great.
of like the 8 that we didn't have to change before.
Correct.
And the 4 we had to change.
So now we do need to make this. We need to make the first fraction look like this. So now we are here. We found out what's missing. Now we're ready to do the multiplication. So if I want to turn x minus 1 into this,
I need an x.
you
That's
need
what's
an x.
missing.
So I'm going to multiply by x, but
Must be useful form of 1.
there is no equal sign in this problem, so we must use useful forms of 1. Okay, so we are now here. So next, FOIL or maybe just distribute in this case.
Okay.
And the numerators, if we bring this in here, what do we get?
X squared plus x.
There is no multiplication to do over here. I'm just going to, well, maybe I should keep it separate for a second. Getting ahead of myself. So I'm just going to leave it alone. We did write a note on there. No need for you to FOIL the denominators because there's not going to be any combining of like terms down there.
So just leave them in parentheses form.
Right.
So now, just like the 1/8 and 6/8,
Yeah.
we can put them together as one big fraction, which is one denominator. So that new denominator that used to be an 8 like that is now the x minus 1.
Mm-hmm.
And now we just add the top, x squared
X
plus
squared
x.
plus x.
And then just write minus 2.
Okay, I do want to point out that's addition. If that's ever subtraction and there's more than one thing in there,
Yeah, we
you got to
distribute.
distribute. It's pretty tricky, but we didn't have to do that here, and I put a little note there about that.
Good.
Okay, I don't think there's any combining like terms we can do. Could we factor this numerator?
Plus 2 minus 1.
X plus 2, x minus 1, and that is helpful.
Oh, I see now. There's a useful form of 1.
Yeah, x minus 1, x minus 1.
So if change it to a 1, it kind of goes away.
So in the end, our final answer on this problem is x plus 2 over,
And don't kill a kitten by crossing off those x's.
yes, don't do that.
They are not cross-offable.
We do have to state the restrictions as well. So remember restrictions, we've gone over this a lot this year. You can't divide by 0.
Right.
So it's important that we look at the denominators at any point. So maybe even look back to your original denominators that you have. here, we started with x minus 1 and an x minus 1. So those will help us decide the restrictions. So what can x not be?
It can't be 1 because that was 1 minus 1, and it can't be 0 because of that x.
From this guy. And then if we do this one, that's going to be the 1 as well.
Same again.
So that is our simplified expression and restriction.
Nice.
Okay, should we do another one?
Sure.
Surely.
Surely.
Okay.
All right, we have to factor the denominator. The first one's done.
Nice.
Second one, plus 5 plus 1. Yeah, they share the plus 5, and the extra is x plus 1.
So that's what's missing, quote unquote missing.
Yeah.
So we want to use a useful form of 1 to turn this guy into that.
Right.
So x plus 1 over x plus 1.
So now if you look at the denominators, they match. X plus 1, x plus 5, x plus 5, x plus 1. Same deal.
All right, I am going to FOIL in the numerator, not in the denominator. X squared is the first term. I'm going to end up with a minus x and a plus x, so they do cancel. Our numerator actually ends up being x squared minus 1. I am not going to waste my time FOILing the denominator because we don't need to do that right at the second.
You might have to cancel later.
Right.
See the factor. Ooh,
So-
I see a minus sign.
Okay, so what should we do with that?
Distribute it to both.
Good, so there's really no FOILing to do because we didn't have to do any multiplying in that fraction, but we should distribute this. So I'm going to change, we can do this two ways. We can change it to plus and make it minus x minus 3, or we could keep it a minus in the middle and deal with it later. Okay, so the whole goal was to get two fractions, same denominator.
Got it.
So now we can write it as one denominator. And once you get good at this, you can skip this little step, I think.
Yeah.
I'm just trying to show them where this is all coming from. And now all of these things are in the numerator together with the correct signs.
Can we just put the -1 and -3 together in one step?
Absolutely.
I could do that in one step also.
So minus 4.
Mm-hmm.
Okay.
All right, last thing is to factor the top to see if it'll cancel with anything on the bottom.
I don't think there are any factors of 4 that give us 1.
4 and 1, 2 and 2. Nope.
Okay, so this is an acceptable final answer.
And then the restrictions, x cannot be -5.
If I set this equal to 0, I get -5 and -1.
Awesome.
And those are, make sure you're looking at the denominator at any point. We actually didn't do any canceling, so that takes care of it all.
All right.
I think we're gonna stop there. We got a little bit left in this section, but we'll do that in another video.
All righty. Ta-ta for now.